Hello, class. This will be the first of the recorded lectures for our stats class. So we're going to start right at the beginning, section 1.1, which deals with some definitions and basically talk about different sampling techniques. And so I'm going to share my screen here. And since there's quite a few definitions, I'll be using this PowerPoint presentation, which I will also upload along with the recorded lecture. So the idea in this section is to talk about sampling and talk a little bit about the difference between a population and a sample, which implies the difference between a statistic and a parameter. So just a few hopefully reasonably straightforward definitions, famous last words from your instructor, to kind of get things started. So a few definitions. First of all, the word statistic is the study of basically collecting, describing data, and drawing conclusions from the information. And so that's what we'll be doing for the next 16 weeks. But an important aspect of this definitions of population and sample is actually the population is a collection of pretty much everything that you want to study. Like right now, what's happening is they're doing a census of all the people in the United States of America. They do that every 10 years. That would be considered the population. And what they're actually trying to do is count everybody instead of doing a statistical analysis using a sample, which would be the subset of the population. But this subset actually represents the general idea of the actual population. So we're going to be mainly working with samples and analyzing samples in this class, because it is very hard typically to be able to analyze a whole population, especially if it's really big. So to generate samples, you have to do some sort of sampling to get a group that would be representative of the population. And so we're going to walk through a few of these. The first one is what's called the simple random sample. And theoretically, that's usually the best way to do a sample if at all possible. Sometimes it's not easy to do this one. In my engineering life, I never did random samples. I did something called systematic, which we'll talk about later. But the idea of a random sample is that you would choose a subset of the population, and each one of your choices are randomly selected. And so you can see that this example, excuse me, of what we have here is that suppose there's 10,000 lottery tickets sold and 5 are drawn as a winning ticket. Each collection of these 5 tickets can be formed as equally likely to comprise the group of 5 that is drawn. So that's pretty much random, that you would be able to draw those 5 tickets. And so here's another one where it's nice now that a computer can actually generate random numbers. And using these random numbers, you'd be able to pick certain items or certain people from a complete population. And so if you read this one about the physical education professor, you would see that this one would definitely give you a random sample, where this one here would not. And here you could see that the professor wants to get 50 students to fill out a questionnaire. And the professor has a class at 10 a.m., ours is at 11, right? And has 50 students. So she decides to use those 50 students to fill out the questionnaire. This actually has a different name for choosing a sample. This is actually called a convenience sample. And you can think about how a convenience sample works with regards to making it really easy for the person generating the sample to do the actual sample. So if I wanted to do something kind of easy, like ask everybody in this stats class a question or fill out a questionnaire, that would also be what's called a convenience sample. So continuing to discuss these samples, the next ones that we're going to talk about is what I was just alluding to as something called a convenience sample. And a convenience sample is usually probably not the best way to do sampling, but sometimes it is the only way that you actually can do a sample. So again, an example of a convenience sample would be, say, like, as I showed you before, but let me use myself as an example, is I actually teach a college algebra class. And I wanted to do a questionnaire where I wanted to ask 25 college algebra students a variety of different questions. And I decided to use my college algebra class, which has 29 students in it, to do that. And so it's very convenient for me, very easy for me. And so that's what we mean by a convenient sample. But sometimes convenient samples could be the best way to do something. And I found this to be kind of interesting example where say like you're a construction engineer and you had these big, really heavy concrete blocks. It looks like there's 1,000 of them. And the engineer wishes to investigate this crushing strength, or I don't know, you could just pick any type of parameter that you wanted to analyze on these blocks. And you could see that if he tried to do a random sample of these, it would be quite challenging. Obviously, the convenience sample would be take the ones on the top, closest to them. And to be honest with you, if I was the engineer doing this, that's probably what I would do with regards to that. I think if I found the problem, then maybe I would expand the sampling and try to make it a little bit better. But in this case, here a convenience sample actually would be quite nice. So a couple other samples that we're going to walk through are two that are kind of very closely intertwined together in the sense that stratified and cluster are samples where you take and put the population into groups. And depending on how you deal with those groups on a sampling basis, one's called stratified and one's called cluster. The other one's called systematic. That's the one I used as an engineer. And when we get to that, I'll explain that. And then the last one is this voluntary response sampling, which is a sampling like a Yelp sampling is a good example of something like that. So stratified is this idea of putting a group together in what I would call, let's see, I'm going to get my whiteboard up here. A few different, what I would consider it, categories. So there we go. So the whiteboard's up. So say like I wanted to take our class, and I have no idea, but say like I wanted to take our class, and I'll make 3 groups. And say like group 1 here, and let's use ages. So we'll say like group 1 would be ages 16 to 20. And ages group 2 would be ages, say, 21 through 25. And say group 3, I'd say it'll just be greater than 25. And say if you look at this group, there would be, we split them up and say there were 10 in that group. Say there were 15 in this group. And say there were nine in this group. So that's what we mean by putting, splitting up a population, for example, if we use our class as a population, into different groups. Strata, I think, means this idea of group. And so when we do that, what a stratified sample would be is that, say, like I said, I am going to take 2 people from each one of these groups. So that's what we mean by stratified, is that you choose a number of samples from each one of the group. So there's this other thing called cluster. And the way cluster works is the same thing as stratified. And what we mean by that is that in a stratified or cluster, you take and you make these groups. So I could do a cluster sample in this same group. But instead of taking 2 from each group, what you do in a cluster is you take a whole group. So say like I wanted to take this whole group. So those 15 people. And so that's what we mean by a cluster. So that's the difference between the cluster and the stratified aspect of it with regards to that. So the next sample that we're going to take a look at is what I used as an engineer. Let's see if I can get the screen shared again. So with regards to this, what's called systematic sampling, is this idea that you take a data point or systematic of every kth item or kth data set or kth person with regard to that. So for example, if I said our class, I give everybody a number and I ask you to count off, and I say I take every 5th person. That would be systematic. In my engineering life, we did a lot of testing with our product. And for example, when we designed the product, we wanted to make sure that it didn't overheat. Sometimes when things got really hot, they blew up. So that wasn't a good thing. So what we would do is we would take the what we would consider the very important criteria of components and put devices on it where we can measure the temperature. And then what we would do is every minute, every hour, every second would be a little bit too quick in the products that I designed. And we would just take the temperature, with regard to that. And that would be a definite idea of a systematic sampling. And here's an example here where you're on an assembly line and you want to do some spot checks and say that starting point will be the 3rd car, and then every 5th car you would take off and do some sort of spot check. And so that would definitely be a systematic sampling, and that's used quite a bit in the technical and engineering world when you're doing things like evaluating a system to make sure that it's working properly. So the last of the sampling that we're talking about is this thing called voluntary response sampling. And this sample is used in the media just to engage the audience. And so here's an example that a radio announcer will invite people to call the station to say what they think. Another thing would be if you posted like a review on Yelp of a restaurant or a review on Amazon with regards to that, is you see that they always send you email requests now, right? Asking you to post a review or post a comment, etc. And so typically you either get somebody that's really happy or somebody that's not really happy. The ones in the middle usually don't respond. They say here negative is usually more than positive. And I personally think you see both extremes, but you never see kind of the middle aspect of it. So those are the concepts of sampling. And the last thing we're going to talk about is the difference between a statistic and a parameter. And they're both measurement of typically the same thing, but it depends on what you're measuring. And a statistic deals with describing a characteristic of a sample. And a parameter deals with a characteristic of a population. And so the idea of S goes with S and P goes with P is the kind of the way that I remember it with regards to that. And so here's a couple examples. So here, 57% of the teachers at Central High School are female. So the whole population of the school would be the Central High School. So if it's a population, then it would be a parameter. We're here in a sample of 100 surgery patients, who were given a new pain reliever. 78% of them reported help, right? Significantly pain relief. So when you see that they're taking a sample, then the 78% is actually a statistic instead of a parameter. So that ends section 1.1. Hopefully it was a nice way to kind of get introduced to this. So what I'm going to do is post these to our Canvas account so you can watch these at your leisure.